Hello, hello. Alright. I was gonna make like a countdown thing in Zig. I'm trying to do everything in Zig right now. It's just nice to, you know, keep learning and keep doing stuff. So what I was trying to do here was make a sort of countdown thing where it would show in the terminal, so I could show it in the window, because I'm basically only working with, well, not only, but I am working a lot with the sort of terminal here and the, you know, NeoVim here in Linux. And so I thought that, okay, why don't I just make a countdown thing in here? It should be pretty easy. And yeah, started to, as I thought, yeah, I had like half an hour before I started here. And so I started to try and make something here, or I guess excuse me. Oh, sorry. I guess like 15 minutes I had like, so I was like, oh, okay, so how do I actually set the cursor to somewhere on the screen? How do I clear the screen? How do I know how big the screen is so I can set the cursor to like the middle? But I thought it was going to be like a small fun project. So let's just continue on here, because I think the only thing missing now is basically getting the size of the terminal, and then basically just the logic around printing the right stuff. So, but the last puzzle I need that I don't know yet is the how to get the size of the terminal. And I did read up on, well, I did a quick Google, and there's something called the IOCTL. Let me show you the browser here. So yeah, so something here that you get something out here. Where was that? Well, there was this Stack Overflow anyway. So you have the Windows size W. I guess this is like part of the IOCTL thing, maybe. Yeah, I think so. So you get the win size, so that some kind of thing, and then you do some sort of, I guess this is like some sort of dynamic call into this IOCTL function, and you request the win size, I guess, and then you get this, put this as a pointer here. I'm gonna guess that's how I don't know what this 0 is, but, and then you get the rows and columns. But I'm not sure how that works in Zig, so I was trying to find out about that. So like Zig IOCTL or something, I don't know. Yeah, so here's one person who did the same thing, and an example from Standard Progress. Okay. So is this in actual standard library? Win size. Wait, is this from the standard library? Like, where could you, or is this just, no, yeah, this is like 1300 progress. Oh, is this is like for maybe they're using this internally. All right. Okay, so we have POSIX. Okay, here we go. File descriptor. What file descriptor? I guess 0 is system out then. Okay. Well, that's for Linux. I'm not sure how that, if that works on Windows, but I guess I only use it for Linux anyway, so I could just put in 0 there, I think. Yeah, I mean, sure. Let's do the same thing here. I guess we'll just copy this entire thing. All right. And then I never seen this, but apparently this is how you could sort of set the terminal, like clear the screen, like basically send some weird commands to the terminal to do some stuff, like clearing the screen, setting the cursor. So that's interesting. I never knew how to actually do that. So, oh, I should use this more maybe. So this would be like get win size, and we get the win size. I guess this could be an error. I guess, and we'll copy this in. Oh, I see. Okay, yeah. Let's just copy this in here. Okay, so we got our win size here. Standard POSIX win size. Curious that this is like a lowercase w. Usually with types, they are always like capital. I'll check in the current version if this is the same. Win size. Apparently it is. Maybe it's just because it's like one of those things that only exist. No, it's public. Maybe it's because it's external. I don't know. Whatever. Okay, so we got this win size here, and we have everything to 0. We then call this IOCTL something control something something. With the file descriptor, I'm gonna say 0. I'm gonna call this like terminal size because that feels more appropriate. And yeah, we got some weird things going on there. So this is like a terminal thing, maybe, and this is like whatever operation you wanna do, and then you have this win size thing that we store it in, and then we have if the error is 0, I guess is the usual thing, I think, and then if it's more than 0, you have some sort of 0. You have some sort of error happening, and so well, I want, if we can't get it, we don't really know the size, so I'm gonna return some sort of error. Global progress. When's it? Oh, I see. Yeah. So this is just return win size. There we go. All right. And this one is, well, it's gonna be this POSIX, standard POSIX. POSIX. I'm not sure how to pronounce it. Alright, so let's see if this works now. So I'm gonna get the terminal size. Right, let's do a try here. And then I'm gonna, I will actually import one of my libraries that makes it easier to sort of do stuff with the terminal and stuff. So like print, like just, you know, printing. Forgot how I did this, but let's just sig.io dependency. Also, my LSP for some reason doesn't work again, so we have to make do with that. All right, that's the dependency. We have also roots module, add import. Yeah, I guess I don't really like the underscore here. I rather usually have like dash, but you know, you can do this in when you import. You can type whatever you want here for your, like what the import is named in your project. So I'm gonna choose to change that to a dash there, and then this is gonna be the module, I think it's called, pretty sure, and then this is like, I think that's how it is. We'll see. All right, so let's do a run and see. Right, member functions with 2 arguments. So dependency. Oh yeah. You also need to specify the target and optimize there. That's right. Okay, so it went further this time. Okay, unused log. Okay, now so it seems like this works now. And what we want to do is we want to, I forgot what I call this. Maybe I called it like printf or something. So this is basically like the print function, and you can have, so let's say term size, and this is, well, I have to look up. So it's row col x pixel y pixel. That's interesting. So we have, well, let's do columns first maybe, and then row. So x and y, you know. Okay, and let's try this now. Oh yeah, I have to do a try there as well. Now what's the issue here? No module name. Oh yeah, this is with a dash now, as I said before. And there we go, we got 9912. So let's count this. 1 2 3 4 5 6 7 8 9 10 11 12. Okay, yeah, that seems to be, yeah, and 99. So that seems to work. Nice. Awesome. And all right, so let's maybe I'll put these in library as well. I mean, I found it. I've actually copied this from another library, so this is just straight up copied. I mean, I found these functions and put them. They were in different files, but I put them in here just as a super convenience. And yeah, just I'm gonna try it now. I don't know if it works. So let's try it. Let's do a clear screen. And oh, we need a writer, so. Yeah, we actually have to do, well, let's just change this to be, let's just use, you know, IO printf instead. Whoops. And well, we need like write all, whatever, I'll just do this. And so CSI plus 2J, that's apparently the magic word here. Let's try clear screen first. And so you don't need a writer anymore. There we go. And yeah, I mean, it seems to do something. I'm not sure if the clear screen works terribly well in this sort of buffer thing here with Vim, but let's now. So it did something. I mean, we sent the proper sort of command, I guess. Let's try this one as well. So we'll remove you and we will say printf. Oh, I see. Oh, yeah. So that should be the exact same thing. Yeah. So let's remove this. Well, let's see. Set cursor. So yeah. Okay. Let's do set cursor first. And so I don't know. Let's do like term size. Well, yeah. Term size column minus. So it's like 45 is like in the middle, and then y is, let's just do 0. Okay. So I just want to see if it works. Okay. Well, it seems to work, except it's 55. Again, there might be something weird going on with the clear screen thing. But it did set it to 55. Will it be the same if I run it again? What if I do clear and then run? Okay, why is it like... Okay, yeah, okay. I'm just not mathing correctly here. The column was 99, right? So this won't be like... this, I mean, 45 is half of 90, so this would be more like... yeah, 45 plus 9, which makes sense. So if we remove like 10, then that would be... Oh yeah, I mean, we need to add 20. There we go. Now, so this is now 45. Okay. Right. So let's do... let's see. So if we want to print something in the center... Actually, we want sort of the layout we need is sort of like, it's gonna be almost like two. We divide the terminal in two equal side by side on the horizontal. So we have one side on the left and one side on the right. And so what we need is we need the center point. So I'm gonna do like center, like half width. Or half column, maybe, because we're dealing with the terminal. And we'll do a div at, I guess, I don't know, yeah, that should be fine. Divide by 2, please. Okay, so that's the half. Right, and so the left part of the text is going to be the same every time, so we know the length of it. So I will call this the label, and this will be you know, stream starts in, and then we're gonna have label X is gonna be half column, or label column, maybe, whatever. It's gonna be this minus the length of the label. There we go. And so now we can set this to... Also we need like half row as well. There we go. All right. So both of them are going to be at the half row. So this is going to be half row and Y. And this is going to be label column. And then we'll print the label here. I mean, either we can just use the label and an empty thing, or we could say S label. It doesn't really matter. It's all gonna be the same thing. And then, yeah, so that's the label. So let's see how that looks. There we go. That looks good. Okay. And then we also want to do the time left. So we need some sort of time. So I'm going to just make up something here. Time left. How we do this actually? I think actually Zig has like duration built into the formatters. I'm not sure how to use that actually, but formatting. Okay. All right, so here. Hey, abbreviated. How's it going? Welcome. Yeah, I started off. I do have a plan for the game code today, but I started off like because I've been starting to sort of plan my streams at like, you know, half an hour or an hour ahead now, and so what I'm building now is like a terminal based countdown to when the stream is sort of starting. Planned content, yeah. Yeah, I'm trying to get there. Well, I thought that maybe it's good if I at least start working towards having more planned stuff. But yeah. So what I'm doing now is I'm building a terminal-based countdown thing, and I thought that this shouldn't take too long. So, what I'm doing now is I'm trying to find out how to format like a. I mean, we could just build our own formatter basically for this, but Zig actually has like a duration formatter built in somehow, and I'm trying to find it. Print. No, this is like capital D, I think, for duration. I'm pretty sure there is something. No? I'm pretty sure I had something. You know what I do for T in sequence 1 to 60 echo? Yeah. I was thinking of using like the built-in thing for duration, but so I'm trying to find it. I'm pretty sure I read something about it. But it doesn't seem to be S, no. String literals. Where's the part with the actual formatting? Maybe I need to look at the standard library. Format. Somewhere in here, maybe. Whoops. Parse int. No. Is there something with duration in here? No? Am I crazy? I'm pretty sure I read something about it. Okay, you know what? Forget it. I'm just gonna do it here. So let's say this is like, I don't know, in seconds. So let's just do like 30 minutes or something. Right? And so we'll have like seconds. It's gonna be we do have like mod 2. No, what am I doing? 60. Right, so that's the seconds, and then we do +1 maybe, or I don't know. And then minutes is gonna be div floor. All right. Yeah. Okay. And then we're gonna have that part of the text as well. So actually, let's move this down here, I guess. All right, and then we set the cursor. Well, actually, we don't need to set the cursor. It should already be at the correct place. And so here we will do printf. How's it going, by the way, with your project? Let's see. Oh yeah. Sorry. Let's see, printf. Okay, yeah. So this is just this, and then minutes, seconds should be correct, right? All right, let's try that. There we go. Well, okay. You can see there's like a 0 there, so we have to sort of make the seconds label, I guess. If, well, we can do just a dirty thing here. If seconds is less than 10. Wait, no, this doesn't work. We actually have to do. Okay, we have to do this. Yeah. Let's make a new function here. Print. No, let's make it directly here. So that's the minutes. Minutes as string is going to be an array of 2 characters. Okay. Then, no, this we don't need to do that. We just need to do this. If minutes is less than 9, print 0, then print the minutes. If this is, I think this is quite nice. It's kind of like streaming. Yeah, we're using the streaming nature of this to our advantage here. I'm not sure if there's a way to build this into here. If there's a way to sort of format the number with this formatting specifier to do the same thing here, but that should work. All right, let's say there's like, let's say it's like 9 minutes and, well, let's say 8 minutes and 12 seconds or something. Yeah, so that works. 02D, right. Well, I can try. Let's do it on seconds because that's the one that is. Yeah, I think SIG has like its own weird way of doing things. Well, that's not necessarily weird, it's just not used to it. There might be a way, but you know, let's just do it like this. It's probably gonna do the exact same thing anyway. All right, so it doesn't. This code does not need to be perfect at all. Okay, so now we need to put this in a loop thing. So this would be. I'm just gonna have like print countdown. And I will put you there. The term size could be, you know, we could get it every time, just in case the size changes. So we need to react to that. Reactive programming here. Okay, so now we call this print cooldown, and it should be, you know, it should be the exact same thing, except something is wrong. What is wrong here? Did I? Oh, I need to do try. There we go. Okay, now what we do is we determine, we send in time left instead. Let's just make this a U size to make, well, it doesn't need to be a U size. Let's just make it like a U64 or something. I don't know. U32. I don't know. Okay. We could also get the thing, get the arguments as well. And how you do that in Zig is not by adding things in here. I don't think you can add things in here. What you would do is you would yeah, there's some, well, I don't have auto completion now, so this won't work really well. I'm just gonna see, there's something with like process arguments, something like that. All right, so you can call standard process args to get the command line arguments. So now we get some, now we get like an iterator here. So I want to make a original time left, or let's just call this time left. And this is the same thing, like whatever. And then we're looking, so the first argument is going to be the program name. So we need to look at the second argument. So we need to, we'll skip the first one. We don't care about that. And then we'll get time left as string. If we don't get it, we return. Actually, we can like, we can do like print usage countdown time left, something like this. Right. And return. Okay, and then say, hello two-step, how's it going? Working on a counter in terminal. Yes. If you want fixed with d:0. Oh, okay. I know they recently changed the formatting thing, but time left. Oh yeah, it's constant. That's not used. I'm just gonna do this for now. Oh, okay. That seems to work. So thank you. All right, cool. Let's just try this again, like 8 plus 12. Yeah. I think I want to calculate typing intensity so I have different animation focused typing versus casual typing. Oh. Nice. Why do you need to try those things? The prints, I'm guessing. Or, yeah. So, well, because they can, it's like the standard out, the print function in standard IO writer can return error, so that's why we have try here. I'm not sure what kind of error it has. I mean, I'm guessing it's like some sort of terminal based thing error that could technically happen. So that's, I think that's why they have like maybe some sort of buffer thing. I don't know. So, are you using libv-axis? Writing can fail. No, I'm not. For, you mean, is that, what is libv-axis? Can you omit the try statements, print counter, and only use try and main? I don't think you can, actually. Each thing that returns here actually it's like returning a value. So actually you could do this and you get this error here. This is like an error type, and then you have to sort of well, now it's kind of explicit that you're grabbing the error. I'm not sure if you can do this actually to make them go away. I'm not sure actually, but we can do it. But you know, I am trying. It's kind of like, I mean, it's like exception handling basically. You know, when you say try, you're basically saying, okay, it's gonna bubble up to the parent or to the caller to handle the error. Expected. Wait, what? Oh. Oh yeah. So here's like. Here is like term size. Now this is an error or a term size. So I have to do like catch error. This is basically what it's doing. It's catching the error and then returning it. So that's the return type there. Here I have to do like try, I think. We'll have to. I'm not sure if this works here. Yeah, error union is discarded. So it's gonna complain here. Apparently. Yeah, and it's good because then the error is very visible where the errors can happen. Even though, you know, some standard functions actually assert instead of having like these kind of errors. But so sometimes you just get crashes instead of being able to handle the issue. But yeah. Okay. Now, back to this. So we get the arguments. I'm gonna store the time left in this thing here. Maybe it makes sense to also have like minutes and seconds here. So I will make these like that. I mean, we could make a struct, I guess, as well, but whatever. So this will be like minutes times seconds. And time left as string is going to be this. So now it should have a string that we can look into. And right. Now, I'm not sure if I have done much with parsing. Well, I've done like JSON parsing a lot, but well, I guess we could use that as well, like parsing like just a value, like a number. I mean, I'm not gonna use dots or anything like that, so I'm just gonna say actually, we can do this. We can say split iterator, split scalar, u8, and then time left as string, and then we'll have this as a split. So we'll split on that, right? And then we'll say minutes as string is going to be split iterator next, and seconds if we don't get anything, I'm gonna usage function. I guess technically this could be an error. I think we're just gonna do printf usage, and then we're just gonna catch unreachable here, whatever. So now we can, instead of this, we can say return usage. All right. Also, let's check if the length is 0. We also return usage here. And then this would be like, instead, like minutes, seconds. All right. Yeah, they are a very special type, abbreviated. They are called error unions. Yeah, exactly, two-step. And they have they have like a very special meaning in Zig. They are very like, they are not treated the same as everything else. String to int. No. Minutes as the argument. Oh yeah, I guess we don't really need seconds. That's true. I'm not gonna specify the number of seconds. Okay, let's just remove seconds. And we'll don't, okay, yeah. Fine. Okay, I still have this though. Good point. All right, seconds is out of here, but this is gonna be like 60. There we go, because that's in seconds. I guess this could also be like seconds, whatever. Minutes. No, we need the time. We need it in seconds. We need it in seconds because it's gonna get like countdowned. I'm not sure about the timing here though. We need also, yeah, now the last piece here we need is time. But okay, let's convert this first to a number. And I'll just do this the way without using any standard library or anything, because I don't have that off the top of my head. I could use the standard, like a JSON library, but I'm just gonna do this. So I'm gonna do for length, right? So we got this. I'm gonna do n here is equal, well, okay, this is kind of awkward. I think I also need to you know what, we could use this, we can do this super simple actually. We can force the format to be this, where xxx is minutes, example 0:30 equals 30 minutes. Okay, so we're forcing this format here. That's gonna be stupid easy here. If the length is not 3, yeah. We will also do trim. So this would be this, and this would be something like this. Okay. All right. let's see, if it's not 3, then we don't care. We're gonna go through that, and then we're gonna say first is like minutes plus equals, and then it's gonna be this I minus, I think it's 0, right? Because of very convenient there. And now this is a U8. So let's do as U32. And then we add, no, with times by 100. Okay. Let's just do this, whatever. I was thinking of taking the power to the whatever, but I'm not gonna vary the length anyway. All right. Okay, now we need to figure out the timing here. Let's try this now. This should show like the usage or whatever, or it's gonna crash. Org iterator. Expected this, found that. Okay, you need to be a var. Okay, there we go. And we will say this. No? Or is it? Hang on. Come on. Clear. Is it this? No. I will do this to debug here. Not sure what's going on. Invalid format. Oh yeah. Orgs. Okay, so that looks correct. I think you had a good idea with the varied length. With the n, yeah. I was thinking of having like the dynamic like that, but you know, I'm just gonna hard code this. Now it's solved now, so I don't need to. Because I think later, if I'm gonna be more serious about this, I'm gonna implement, probably just specify the a time instead, like you know, in my time zone, like a time like 12 o'clock or something like that, and it's gonna figure it out. So I'm not gonna spend more time on that. Why is this? It's trimmed, right? But that seemed to be correct, right? Why is it showing the? Oh, if it's not equal to 3, there we go. Okay, we got some integer overflow. Minutes times 60. Oh, wow. Oh. I should set it to 0 to start with, yeah. There we go. And I can choose whatever I want. Okay, cool. Great. Now, yeah, now is the time thing. So I need to look at some sort of time in the thing. Standard time. Let's end the stream. Yeah, exactly. Now I was thinking like, yeah, start the stream. I put the thing up on the terminal or whatever, and it's gonna like count down, and then just a very simple instant timer. It's gonna be some sort of like timestamp. That is the time. Okay, yeah. So we could get the timestamp. We could do like sleep. Maybe. My thing about that is like, yeah, nano sleep. Spirits wake up, so no positional time is guaranteed. I mean, I guess it doesn't really matter. I guess we could sleep for 1 second, and then we could sort of check the timestamp and look, you know, display the correct time or something. We could even sleep for, you know, 100 milliseconds or something like that. But this one was like seconds. Seconds and nanoseconds. Thread sleep. Nanoseconds. Okay, Windows is using something somewhere. Kernel thread. Okay, it's just calling that. Yeah, I mean, I guess we'll just use this. I have to multiply. I'm not sure. Nanoseconds, what is that? We have milli, micro. Is nano after micro? One. Okay, yeah. Yeah. Okay, so sleep on standard.thread.sleep, and we just need to do that. Okay. Right. So first we'll do that. There is no while do, but we could just do while true. Yeah. Let's do while. Let's do while true. We'll do minutes. We'll do sleep. So this would be like, now it's micro milli seconds. Wait, 6? No. Yeah, there's 3, like milli, micro, and nano. I'm pretty sure it's 9, yeah. So now we're in seconds. That should be 1 second then. Let's do like half, or let's do that. And then we'll do, now we need to check the timestamp, which I guess we could do this here. This is in seconds, I think. Yeah. So it's like, standard time timestamp. Okay. So I'm gonna grab the start. Let's do like elapsed seconds, maybe. Wait, no. No. Start, and then here we have elapsed seconds. It's gonna be start. No, timestamp minus start. If wait. Let's do minutes left. And then minutes left equals to minutes. No, seconds left. Seconds left. And this would be seconds left. And then seconds left equals start minus elapsed seconds, right? Something like this. I guess we'll find out. And then we'll have if seconds left is 0, I will do something else. I will break. Okay. Then we'll do print something like is starting any minute or something like that. Any second. Sorry. And we'll basically do the same thing here, except we will say the label is going to be stream starts any second now. I don't like exclamation points, marks, whatever. Set cursor, yeah, but then we don't do this. Also, we want it centered, so what we're gonna do is we're gonna divide this by 2 as well. There we go. Okay. Alright, and then we do try print this. And then we're basically done. But then it's gonna go into like terminal mode. So I think I wanna just put this to sleep or something. I don't know. How do you like, could you sort of indefinitely put it to sleep or something? I don't know, let's just I mean, you could have like a while true. I guess you could do this. And we'll add, you know, every second or something, or 5 seconds. All right, let's do every second. Okay, what's the issue here? Cannot assign. Okay. Oh yeah, so this still needs to be mutable. There we go. Expected U32 found I64 87. Okay, so let's make I64 is insane though. Maybe I'll change this to 64 just in case. Let's replace this with 64. All right, so it's easier. I guess it could also be like I64, make it even easier. Wow. Okay. It seems to work. Until we do this here. Seconds left to start minus. Oh wait, wait. The start is that, right? It should be like minus. It should be minutes. This is the starting seconds. And then we subtract by elapsed seconds, right? There we go. Like plus. Because it's signed. Well, it seems to work though. I wish I could do like 10 seconds now. I mean, we could just say minutes. Yeah. Signed it, yeah. So, could we do... Why is it like... Why did I put a plus there? How do we fix this two-step? Do you know? Otherwise, I will have to check. Print. No. Where is that? Print function. Writer print. Here we go. Cast to unsigned. I wanted to fix it with I wanted to see if there was a... So here's the format thing. Here's the documentation is on the print function in the standard IO writer. And so we have like argument, specifier, fill, alignment, width, precision. Alignment, interesting. Fill. Okay. Yeah, I think this is what we do. What you showed. Specifier type dependent formatting option determines. Okay, yeah. I think that's this part here, like the D for number. Integer value. T S X. It would be cool to show like X, so it shows the countdown in hexadecimals. Okay, but argument, numeric index of field name arguments should be inside. Oh, so you can specify that. Oh, I never thought about that. That's interesting. Like if you just put a struct in there. And this is nice. Yeah. Okay, but that didn't help. Maybe you can't do it. With just the formatting. But yeah, I'll try the cast to unsigned. Thanks. So, as U64. Actually, this could be like U32. I'm gonna try. Because it's an I64, so it should be castable to U32, right? And then I have to do like int cast. I was just gonna check if it could sort of coerce it without my help. Okay, yeah. There we go. There's a cursor there. Can you hide the cursor? I'm gonna look at this library that I found, which I mean, you should just be able to go to look at the manual for basically like terminal things, but this is the library that I found that I basically stole the code from, and we have this cursor, which is a really nice library here, except I was trying to use it, but it was like in the old, it hadn't updated the Zig version, so unfortunately, so I couldn't compile it. But basically you have this sort of prefix here that tells the terminal that you want to do some sort of command. That's what I'm getting from this, and then you can write whatever you want here, and then I guess this is the arguments, and then maybe the sort of command or something, I don't know. So you have like cursor mode, I'm not sure what that is. Cursor mode, okay, we have blinking, oh. Well, unfortunately there's nothing for just hiding it. Oh, I guess this one, hide cursor. Okay, let's steal that. I wonder if you exit with this mode set, if it's gonna keep. I guess you can also, I mean Zig could also, I guess, or I mean Vim. Vim actually hides it here as well, so I don't really need it, I guess. It's also nice to see that it's actually focused here, so I can, yeah, maybe I'll keep it on actually. I'm just gonna try it. That's the ANSI escape thing, okay. Well, I never encountered that, so that's really nice, because I always wondered how, you know, libraries like, what's it called, the curse? Ncurse? What's it called? Yeah, something like that. Like how they actually work. Curses, I think. Ncursors or something like that. Alright. And let's just call this in the main function over here somewhere. Hide cursor. Let's try like 1 minute. Oops. What's your issue? Oh. Okay, yeah, it seems to work. And I guess we know now that it's hidden. So if I escape from this, will it, okay, it keeps this, the sort of hidden, it keeps the hidden cursor now. So now it's hidden forever. Interesting. Can I then say, this is like the command for show cursor. No, wait. Well, it's not really printing it. I guess, could I do echo maybe? No? Those who used to add colors and do all kinds of cursed stuff in terminal, like clear screen, move cursor to some position. Yeah. So I have this. That's how I'm centering it. I stole this code here to center the cursor. Well, I'm using it to center the cursor. So how I do it is I have this get terminal size where I'm using, like, I know that I'm running on Linux, so I know that this should work here, but I'm not sure how Windows works here. But I run this IOCTL. This was also like I get, maybe it comes from like libc or something. I'm not sure actually. or maybe it's an OS thing. I don't know. I mean, it's POSIX, so I don't know. Anyway, I call this to get the terminal size. So this works really well. And then I have clear screen. I have set cursor to a position, X and Y. Hide. Yeah, now I have like hide and show cursor as well. But if I control C, I need to have like a, you know, a signal handler or something to get out and show the cursor again. So I think I'm just not gonna do that. I'm not gonna do that. There we go. I'm just gonna exit and get a new one here. And yeah, because I can do this as well. I get this line at the bottom here from Neolink, but I will. I think this prints text in red. Echo. Okay. Yeah, I just tried echo, but it didn't work. At least for that command. Maybe it works for that. Did you try it? Do we have to have like dash dash? Oh. I mean, what about this? No? Yeah. I don't know. Yeah, there we go. It seems to work. Cool. Alright, so there we go. Now we have the countdown timer. So BRB? No, I'm just kidding. Alright, so let's... actually, I need to do something here. One second. So let's do like 5. We'll do 5 minutes and make a trial run here. Yes, I'm not gonna be away for 5 minutes. I'm here, but I will. I'm just gonna send a message here. All right. Okay, there we go. Awesome. So now we have that. Now I want to just make some sort of well, I can do this. I can do so we'll have like alias. How does this work? I forgot. Oops. Well, here you can see my aliases, I guess. So alias. Okay, so it's like countdown is gonna be. Can you do like? Can you execute it in a thing? Like if you have CD here, and then I think you have like this, right? And then or is it this? right, and then brown. Oops. And then I'll put that in profile or something. I should also add a... There we go. Perfect. Yeah, double dash. Okay, cool. So that works. Great. Now I will... What's this? What is happening now? Get me out of this. Why is that on there? Why is that on? Get me out. Okay. I will exit. I'll just see if this works here. Countdown. There we go. Awesome. And what I was thinking also is I could do... Oh, okay. So it actually it actually does move you to the thing, but it doesn't really matter that much because I can do this and then count down something like this. Oops, except I guess profile is not run here. Shell. Bash profile. Also, I need that. One second here. New Vim, or yeah, new Vim terminal profile. Profile. Why is it not running the thing? Is it because it's like a different shell or something? Set shell bash L. Okay. So no, dash L. What? Oh, okay. So there's some sort of error happening. Okay, whatever. I'll just run it from here. That's fine. Anyway, back to what I was dealing with. So last time we did a bunch of I was changing all of these devices to use a state machine system instead of the current sort of custom device system that we have. And so now everything is converted. And yeah, I did a little bit off stream just to make it quicker. What I also did was change the save thing here. So now these ones are like specialized kinds of. So this is like the saved state of all the different devices in the entire game. And they are stored using this state map alias, which takes a device type here and makes a state map which maps like the ID of the entity to the state of the specific type that you put in here. And what it's basically doing here is we make an ID array hash map that has like a UUID as a key. And then we just look up the field type of the state field of that type. So if the state field doesn't exist, this is a compiler error. But if it does exist, it's just gonna take that type and whatever. Yeah, that's just a convention we have. Like we have state on each of those types. That is what's going to be saved, which became like a pattern here. So that's why I sort of made this like this. So all of these are basically the same thing. We could also make them into a list and automatically, you know, make a struct that has everything. But I'm not ready to go that far into the automating the saving for these right now. It's easy enough to just add it here. It's gonna be, yeah, just a matter of testing to see if it works. Also, I'm not sure why is the LSP always not working? Wait, 0.14. Why is it 0.14? Oh, did I change that? Okay, well, anyway, I guess we'll have to live without it a little bit. What else? So, well, here you can see an example of using comp time to automatically loop through all those fields and write their array maps. So you don't have to sort of spell out every little one because we want to save all of them. And I mean, we might just write this out. I mean, we're using the Cbor library, which I contributed to. And so I think we could just make a custom thing for, if it's not already there, a custom sort of map writer or Cbor sort of encoder for those types or for that type, the ID array hash map here. The thing is the thing with that should work actually. So then you don't actually have to do everything here. You could just say write value one time, which is just this entire save thing here. So that would automatically save everything into the thing, into the file. Anyway, so that's something I might look at later. But let's see. So then we also have load, which is sort of the same thing here actually, because instead of writing, we're matching values and stuff here. So that could probably also be sort of simplified by implementing a decoder in the type that we have, but that we need to do it. So, and here we also have like match devices, kind of the same idea here. We're looking through other fields and stuff. And then store devices. So what I did here is like the part of the conversion here is this part here. This is the inner part here is the same. So we're basically looking through all the devices manually here, because all of them are kind of sort of the same, but also not. because they are yeah, they might have special cases where they shouldn't be saved, or when they should be saved and stuff like that. All right, have a good one, Two Step. Thanks for joining. And then yeah, so here one we have like initially open is this specific thing has an initial state which you can set depending on if you want the door to be open or closed from the start. And so if it's already open from the start, and then the state, actually now we need to look at the state here actually. There we go. And this is restored state, that's right. I was changing this. This was like the last thing that I was doing here. Let's go back here. If, yeah, it's initially open, that means it's like from the sort of initial state that it's loaded into, like when it's first created in the scene. And if the current state is open, so this could be closed if someone closed it somehow. If it got closed, then the state should be closed. But here it's like, okay, if it's open and if it's initially open, then we don't need to save it. So we only save if it's open and it's not initially open, or if it's closed and it's initially open. Right, makes sense? Okay, so then we have this if. Then if we should save the state, then we set the state in our memory map here, so that it's, this is what's going to be saved later when we close the game. Is gonna or when we actually like write to the save file, this is the source map that we're looking. So we're changing that, so the next time we save, we get this value here. Yeah, and here's where we actually set the actually this needs to be the state now, not the signal. There we go. All right. If we shouldn't save the state, that means the state is the same as it was when the door's initial state, so we just remove it from the map. We don't need to store it at all in the save file, so we just remove it from the map. And that's the same thing with all of these different devices here. So you can see a pattern here, but it's a little bit different for all of them. But what is the same basically is that we are storing some sort of state, final state, if we need to, or we're removing it from the map if we shouldn't save the state. So we have some sort of initial state, which we have some condition if we should save the state. If we should save the state, we should save some sort of state. If we don't save the state, we remove. So this is a pattern actually that all devices have. So we could technically make this into a pattern and have each device have like a function that returns what state should be saved, if it should be saved at all. And then this guy could just call this function and check, okay, do we have a state that we should save? Then we set our state to that thing. If we don't have a state that we should save, we just remove the thing. All right. So that's a pattern that we could employ here if we want. I'm not going to do that right now though, because I just now thought about this, so I'm not gonna, or I thought about a solution to the problem, but I think I'm gonna let it cook a little bit more and maybe come up with more solutions and find out what works best here. So anyway, we also have the same for saving. This is this is loading. Yeah, this is loading the devices here. So basically the same thing here. We're looking at the entity and looking if they have this component. If they have the door component, it's a door. If they have the toggle, so it's one of these things. Even if it has multiple, which it doesn't, it's never gonna have multiple of these. But if it's gonna have door and toggle, then we're saving both the door and the toggle. So that should still work, but that's not gonna happen because we're not gonna have a door and a toggle in the same entity. Anyway, what we do is we look at the restore state. So this is actually the exact same in every one of these. And the only thing that's changing is this type here. This is the only thing, and this map. So that's the only thing that changes here. And so what I'm gonna do is I'm gonna write a function that does this, but I put in like the type and the map that we want to change. So I'm gonna say restore device type, I guess. The devices type, device type. It's gonna be multiple devices, but it's only one type. So we need the save. I guess maybe we don't actually need the save. What we need to do is we need to do these things. I'm gonna say void for now. There we go. Yeah. So we need this map. This is gonna be. I'm not sure if we actually need this to be a pointer. It depends on the thing, but this is going to be an array hash map of the state type. So I'm going to make a function here called the state device state of time t type. I'm going to make a convenience function here, which just returns the field type t state. So now we can also use this in here, device state of t, and now we can also use it over here. So we can use well, actually, you know, we can just use this directly, state map of t, and we also have the type in there. So we get a type and a map. That's all we need, right? Now this is like map.map.get. Now it does understand this, you know. Yeah, it does understand this. It doesn't understand what get is because it's based on a standard lib function, which the LSP has some trouble right now dealing with that. I'm not sure why, but I'm not gonna look into that right now. I might do it like after the stream or something. All right. Okay. Anyway, so then we have this ID as well. So, well, I guess we also have this if here as well, because we need to check which one of these components it is. So let's also have the if here. So this would actually be, this will be t, and then we just assume that we have a restore state function on this type. All right. We could do something like this, and we don't, yeah. Actually, we could do this. Context has t, yeah. That also works. All right. Now, yeah, so now we can replace this with restore device type. Oops. I'm not sure, the name is kind of fuzzy here, but so this would be devices store. The map is self devices stores, right? And then we also need like the entity here. We need entity and entity ID. So let's do entity and entity ID. go. Registry. Oh, we need registry. Okay, yeah. Man, maybe we'll just make the context actually. Maybe we'll do this. It's kind of weird that now we're using like state machine context in places where we might. I mean, it is kind of, you know, the devices do use state machines, so it does make sense in that sense. But this feels like a more generic place where state machine context maybe shouldn't have a place. But it is also used as like a registry, you know, ECS context as well. So, well, let's just make this here and let's see. So we have the context. Maybe the ID should be in the context as well. Well, I don't know. Let's do that. So now we don't actually need to create the context. We already have it. Okay, so here we'll create the context instead. And we will now do this. The thing is though that this should return some sort of, I guess, a boolean, maybe, because we need to continue here. If actually what's happening here is like we have the state. If it exists, we don't need to store it, but we also don't need to check any of the other things, right? So I think if we get in here, we'll just return true, right? And here we return false. So we don't need to check the other types because it's not going to be multiple of these types. So we have to check if, then we continue. Right. Alright, so we provide the context, remove the entity. Okay, and then we do the same thing for all of the others. Toggle chest. Overboard. Let's just do a macro here or whatever. And then we will go here, copy. Okay. Yeah. And here's also the thing, if we make this more abstract, we could also make a loop where we just provide these in a list and it will know exactly which to go to. Why is this doors here? Toggles, chests, fogs of war, there we go. Okay. All right. So, anyway, let's do some testing now. So, because whoops, source, come on. Failure. .173, no field name state in device component. Oh. Yeah, okay, same thing here. I think this will trigger a unused error here, yeah. Is this also unused now? No. And also, I guess, since we're not using the device component, we should actually do views of doors and all these as separate things. Not do it like this, but do it like, not do it like a view of device. So what this is doing is getting all of the entities that has the device component, but that's not actually relevant here. What's actually relevant are these components here, the door, the toggle, and everything else. They're all the different device. So actually we need to sort of invert this, and we need to sort of make a view of all of those things. Well, one for each. And so, yeah, so actually this would be more like yeah, like doors equals basic view devices door, and then we loop through those, and now we don't need to try get, now we can just get the door. And we can use it directly, so this would be, yeah, that now this is how it would be instead, because now, yeah, so we don't actually need the devices here. It's also probably more optimized anyway, because we're looking through all the relevant components and not looking through all the components and then having a bunch of ifs to check if they have the type or not. Because I believe this is just basically accessing a straight up array, and then we're just looping through it. So anyway, yeah, so that's gonna happen, but let's just check if this works at all first here. Okay, but I do have some error here. Oh yeah, I get the entity ID. That's something that we also actually need to get now, like that. So there are things there that we should probably I'll probably make like separate functions for each one that provides a state like this. Let's say you have should save state door, or get state to be stored. This is just an example here. It's a very bad name here, but should or get state to be stored. So what's this doing is we should supply maybe these things. We're looking for a nullable, and then it's like this the device state of the door. You know, we're looking at these things, and if we should save the state, we return door state. Otherwise, we return initial. Wait, no. Otherwise, we return null. Yeah. So return null if we shouldn't save the state. We return a state if we should save the state, and that's the state that we need to look at. So, and then we have the door is just the device door. And what else do we need? Nothing. Okay. So what we do here is we get the state to be saved, and we just pass the door in, and if actually we could just do this, and we just set that there. So this is going to be the pattern that is basically going to be in every device. So I think I want to actually have this. The only thing that's changing is this function here, right? So yeah, and this type here. So actually all of this is the pattern. All of this could be put into a function, store device type, and we'll add like, well, we need the type. We need the registry. Okay. Yeah, so we'll create a basic view. Now this is not doors now, this is like devices, right? This is device. We are going to get a view of keys. We get the entity ID, we get the device. We need to call some sort of function to get the state. Now this function could exist on the on T here. So get persistent state, something like that. Right? Well, actually, we could just call it on device. And what we need is we need a context. So I also make a context here. There we go. And if we get one, we save it, we put it on the map. And the map is like this. So we need a map as well. This is going to be the state map of T. There we go. I think that does it here as well. The map here. There we go. That is the pattern here that we have. T, I mean, sure, that's, we don't really need T here, but whatever. Allocator, yeah, that's, we can use this convenience thing there. There we go. Seems to be everything in order there. So what we need to do now is we need to implement this function in all of these different devices. We have the functionality already, we just need to copy it, move it into another place. So what I'll do is I will copy this, go over to the door, we'll put it here. So we basically have two functions here. We have one function for basically loading a state, persistent state, and we have one for saving persistent state. So this would be get persistent state, and this would be a door state. Oops. And copy this. Well, let's do that. We get the context. We also get self, which door device I think is called here. Self and self. I think that's what we're doing here. Yeah, we're calling, yeah, on device, which is now, in this case, is the door. Okay. Context is unused here actually, so wait. Oh, yeah, we don't actually need the context. Maybe we need it in. We may need it. I'll just maybe put it there. If we don't need it, I'm just gonna do a quick check here, because it does have things that we might need. Maybe we don't actually need it for anyone. Okay, we'll do this. I'll just remove it, and we'll see if we need it, we'll add it. Okay. Let's see. Yeah, so we don't actually need the context here. It's nice to have for the allocator though, but I'm just gonna get the allocator. I'm just gonna get the allocator here instead. There we go. All right, now instead of doing all of this, I'm gonna say store device type. The device type is a door. The registry we have. The map is gonna be self devices.doors, and T doesn't really matter. Well, okay, now we don't actually need T here, I don't think. Yeah, let's just remove T. Alright. And this returns just a void, whatever. Okay, so we can do the same pattern for everything else, which will simplify this file a lot, and we'll move some of the like logic for actually how to determine the persistent data. Yeah, so store device type. Yeah, so this will call this kind of like interface function here, get persistent state, and it will exist on here. So basically we have these two functions on each, kind of like an interface now, where restore state bears the role of loading a save file, so to set this device to the correct state. Well, not really. Also, it's also just, you know, if you load in a scene and you need to store and you need to load the devices in the correct state that it should be in, then this also handles that. And then we also have this get persistent state, which is the... It's kind of a bad name actually, because we also have another function called get persistent state, which sort of, it's, well, this is actually less correct now, because this doesn't necessarily mean the persistent state, because, well, actually it does. You know what? It actually does. Because right now, what we do with the states... Okay, I'm mixing things up here actually. Maybe we don't even need to get a persistent state. Well, maybe we can reduce it into concepts of what is the initial state and what is the current state, and are they different, then we should save it. So actually what we really need is like, what's the initial state? That might limit us, but I will do it for now. If we need more custom ways of doing it, we could do it. We could, for example, here, we could say if has declaration, if this has, you know, store persistent state, something like this, then we will, you know, we can call that, you know, like this. And then I'm just gonna put, then we can also put like the save as an argument. So if it has this function, we call this and then return or continue. And so that in that way we could, you know, have a custom function for storing that specific thing. So so you could do that as well. And I'll just put it, I mean, yeah, sure, let's just have this there. And it doesn't really do anything right now since we don't have any types that implements this function, but we could keep it there as an option, you know. And then, but if we don't have this custom sort of store function, we use the thing here. So what we do now is we get, instead of getting the persistent state like, well, we get the state. Actually, we need to get the initial state. Initial state. Yeah. So we get the initial state. And we're gonna compare, whoops, if the state, actually let's call this initial state. If the initial state, let's just do this, is not equal to the state right now, we store it. Otherwise we don't. Right? So we reduce it down to that concept there. Okay, and then in our door, instead of doing this, we will get the initial state. And this is just if return if this is true, then we return open, else we return closed. Alright, and yeah, that's the initial state. Okay, so that simplifies this part a lot. And if we need some more complex behavior, we still have this escape hatch out of this abstraction to be able to implement our own way of doing it. All right, but we need to, on every device now, we need to implement get the initial state function, which is very simple in probably like all cases. Yeah, and then it just works. All right, because yeah, we're looking through all the device types, or this particular type, which is in this case is a door that we pass in here when we call this. We call this with door, the registry, and this. All right, that's all we need. Yeah. Oh, and self. But that should be like that, I think. I'm not sure. Wait. Yeah, I think that should be how it is. Yeah. If you need it to be like a member function, you have to have self first, I believe. Always. Okay, and then we have the type, we have the registry, we have the map that we store the thing in. We're looking through all those entities that have that are the door. We're getting the entity ID, we're getting the door type here, or the door data, which is a device. And if it has a special function to store the state, we do that, then we pass in the save so it can do whatever it needs to. Otherwise, we look at the initial state. If it's different from the current state, we store it in the device map save file, save, or not the file, but save data in memory. And if the initial state is the same as the current state, we don't actually need to save the state. Okay, cool. So yeah, now we can just, you know, do this for everything else. So we just need the initial state here. So I'm gonna copy this, go to the toggle function, or toggle thing, get initial state, and this is now a toggle device and a toggle state. And if this is on, then yeah, this should be on, this should be off. There we go. because yeah, this state here, this always now, before we had like intermediate states in these enums, but now it's handled in the in this toggle machine thing, state machine. So this state is always going to be reflecting what can be stored as a persistent state, right? So that's why we can do this here. And yeah, that's the toggle. So now we can just add this line here, and this will replace all of this here, I believe. I'm just skimming through just to make sure that I'm not missing anything, but I'm pretty sure that this is what we could do here. Same thing with chest here now as well. Whoops, what is this function here? Oh yeah, I added some state function. I think I should have the pattern of having the state machine functions in the middle here. Yeah, so that when we go to the end, we go to this one. All right, get initial state. This is a chest state. And I don't think you can have different initial states here. So the chest is always like initially closed. I mean, we could change that maybe in the future, maybe have like an open chest. It's just, that's just gonna be, it's not really gonna be a chest, I guess. It's just gonna be a prop or whatever. But this, so this doesn't depend on anything. We just say it's closed, or it's yeah, it's closed. All right. Okay, and now we can remove all this. So this is basically, if it's open, we save it, which is the same thing there. All right, so then we have fog of war. Same thing there. Get initial state. And so the initial state is always, you know, it's always the same thing here as well. It's going to be, right, this is a fog of war. State. Return, I think it's called idle. Yeah. Okay, this is interesting though, because we do have this fading state, which is not exactly a state that we want to have it be saved as. We either want idle or destroyed. And so this is actually a bit different now. So here is a case where we could have a special function for this. Well, okay, wait. Here. We could have a special function. We could also have a function that returns whatever state it should be as well. So we could have a combination of get initial state and like get persistent state or something like that. We could also move this fading state into a optional, yeah, that's probably better. We move this into an optional here. Right. Maybe. Yeah, I think so. I think so. This initial state is always idle, that's right. Yeah, that seems like a better thing. And so we don't set the state, we set fading directly to this. Okay. And actually also, yeah, when we end fading, we set this to null, I guess. And we initialize this to null. All right. Now this should really be like a constant here. All right. Yeah, and then we also need to draw. Where is that? Draw fog of war. This does not look at state actually. We only actually want to look at fading. So fading. If we don't have fading, okay. Now this should still be true, yeah. Well, actually no. If it's destroyed and we don't have fading, we should continue. There we go. Because if we destroyed it, but we still have fading, we want to show the fading because we want to actually set it to be destroyed whenever we... Yeah, we want to set the state here. Actually, I think I have like set resistance state. No. Okay, whatever. We'll do this. So this is destroyed, but then we also set the fading there. Okay. Because at the point in time where it's starts to fade, that means it's been activated, and then when we store it, we want to store it as being destroyed and not in a fading state at that point. So that should be good. And then here, let's see, so what do we do here? We don't switch on the state. Well, actually, no, actually we don't switch on the state. We do alpha is equal to if we have fog of war dot fading, we do this thing. Otherwise it's gonna be depending on this switch here. There we go. It's kind of a mess. First we have like an if here with a null capture. In the else we have a switch on the state. Okay. All right, yeah. So now we don't. The end result here is we don't need. Hello, Baby Yoda. How's it going? Welcome. Now we don't need a. What is it? Yeah, we don't need a special function for this. We don't need special treatment for this one in the save now. So that's good. Okay, yeah, that was the fog of war. Now we can just remove this part here. This is now generalized. Great. Okay, we've got explosive wall. Destroy device. I'll move these up here. Okay. I want to keep things the same layout. Let's see. What's up? What are you doing? It's good. I'm doing like a. I've been refactoring a lot of things. So I've found this new method of doing things in basically for a lot of different things. Actually, it's like a state machine where the state is basically just a function that is the update function. It's a pointer to a function. So in order to change the state, you just change the function to another function, or you point it to another function, and that's the new update. And in the wake of that, I've been replacing like all of the monster logic, all of the boss logic, the devices that I have, like doors and buttons and stuff. All of those I've now replaced with this new state machine system, and it works very well for all of them. So I'm really pleased with how it turned out. And in the wake of that, I also now am generalizing a little bit for different things. So right now I'm working with the save system, or the save file system, and just generalizing a little bit. So just implementing the patterns that I see here. And yeah, I mean, it takes a little time, but I think it's pretty much worth it. The state machine system is incredibly, I mean, it's very simple in its nature, and it also gets the job done very, very well, I would say. It's very easy to like reason about, and it's very easy to implement, and it's very easy to read. So it's basically like a miracle system if you compare it to, I guess, the previous system that I had for all of these different things. Like the monster system was its own sort of system, which had yeah, I won't get in too much into it, but it was a mess basically. And I mean, I guess that was like more of a I mean, it was a consequence of just implementing something as fast as possible, or yeah, just having something that works. But then I found like this new way of doing it, which just prompted me to sort of, okay, if I don't replace it now, if I don't start using it now, I will never do it. So and I tried it out, and it worked really, really well. And so I just started replacing everything basically with it. But now I think the only thing left that I could try it for is like the player system. Maybe like other stuff as well, like the dialogue system, the quest system. I don't know. There's like, I could basically have the whole game in like that kind of thing. But there are some limitations though. Like I was thinking of having like, because right now there's only one state machine for each entity. But sometimes you need more, like sub-state machines, like state machines within a state machine. That could be kind of cool as well to think about as a concept. But yeah, maybe it's maybe that's getting too complicated to actually have a good system there. But it could be something that you could try out for some one thing, and then apply to other things as well. But right now what I'm working on is the save system there, and so yeah, I'm refactoring a little bit there to implement sort of like a pattern that I saw with the devices here. So basically the only thing I need to save a device is, because each device has a state, which is if it's like on or off most of the time, if it's like activated or not activated basically. And yeah, basically I just need to return whatever state it was initially, and then we can just check if the state is different from the initial state, then we can just save that. If it's not different from the initial state, then we don't even need to have it in the save file at all. So that's kind of what I'm doing here. So I'm implementing this get initial state function for all the different devices. All right, so let's see. This one I think always starts as, I guess, idle. Now this is also a little bit here. This is like only for playing a animation. I don't think this is actually, we don't really need this here. Oh yeah, this is used only for has spawn explosions. But this could be moved into this here. Yeah, we just move it over here. All right. So we don't, the activated, so basically this state is only supposed to have state that are like you know, gonna be saved in the save file. So now we basically have just two states. It might be that all of these only gonna have two states. I don't know. Maybe not actually, because maybe if there's a device that has like more than two states. But yeah, let's see if it's active. So this is basically removed now. If the signal's on, we set it to activated. So actually, yeah, we can still have this as a, so this is where the activated state should live now, in the state machine. So when it's activated, we set this to thing. We should actually set this to destroyed now, because this reflects the persistent state and not the like current state, like in game, or the sort of the intermediate state of activated. It's still yeah. Once it's been activated, it should be saved as being destroyed. So when we if we activate it, exit the game before it changes to destroyed, then load up the game, it should still be destroyed and not activated. All right, we have the animation, we have an update function, and this function now is looking at activated, but it's only using it to check if we have spawn explosions. So we don't need that anymore. We can do this now instead. Okay. And what else? And destroyed, we'll set the state to destroyed. Fine. Yeah, that should still be the same there. Okay, so the initial state is now idle. There we go. Which means it has not been activated or anything. Because we're never going to have like an explosive wall that's already exploded. That doesn't really make any sense. Unless you want to have it for, you know, for just a graphic. Except an explosive wall doesn't really have a graphic once it's been destroyed. Maybe I should add that actually, to make just mark the place where it's been destroyed. I should probably, yeah, that's going to be like, you know, some sort of polish face or whatever. And that is not needed. This one is not needed. What is this? Initial state. Oh yeah, I did that instead. There we go. All right, so that's the explosive wall. Now we can just remove this part. See how much code that is disappearing here. That's the nicest thing in the world. when those that just disappeared. Also, we need to make sure that this is correct. This will actually be compiler errors because it's not gonna match the types here, but yeah, I'll just do this. Yeah, you agree? Yes. Yeah. Oh yeah, so this one could actually, you know, when you're a programmer, you know, extended, retracted, restore state, get initial state, and this is now a extending block thing, extending block state, whoops, not machine, there we go. And the states are extended or retracted if it's on. If it's on, it's extended. And here it's retracted. Alright. I figured out the PMP port forwarding stuff and DNS queries on Windows is fairly low level. Oh, interesting. Oh yeah, you were building some sort of chat thing, right? Or yeah, I think that's right. A chat app. Yeah. Let's see. Just move my build script to make now. Okay, yeah. I'm glad that I don't have to deal with that. I'm not that well versed in that stuff. I've dealt with make, but you know, I'm not experienced in it. So I was using batch. Oh, I mean, that's also something like batch scripts. I always have to look up how to do things. Like, even if I've done it like a lot of times before, it's just so different from everything else. So it's not, I don't feel it's like intuitive. There's like different syntax for each like different concept. Like even just if if statements are the worst. Like, yeah, sometimes you have like one like square bracket, otherwise sometimes you have two, and then there's like different ways of doing the same thing, like a million different ways of doing the same thing. And there's like, yeah. I do believe that the bash script is a nice idea. I wish it had better syntax though, because it's really a very specialized kind of language. Yeah, which does some nice things. Because sometimes you just want to have something that, you know, you can write automated, whatever, different things in it. So, but the thing is, there's no dependency thing, there's no incremental builds. I mean, yeah, you have to do it manually. Yeah. I mean, I use it mostly if I want to have a, you know, if I run some compilation line over and over, or if I yeah, have some sort of build. If I deploy somewhere, or if I clone the code somewhere, I need to be able to just run a script or whatever on a server or something. Or, well, if I just locally develop with Vim or NeoVim, I can just use my the Overseer plugin to run commands. So if I need to do that, I will just do it there. But of course, the bash script will be able to do like easily, more easily, like multi-line stuff. It's good, especially on Windows, because on Windows you get Nmake. You need Visual Studio build tools. You have to install. Okay. To get make Nmake. Yeah, I'm glad I don't have to touch that stuff. It's like you know, there was a time that I tried to sort of, yeah, well, now I want to make something in like C++ or whatever. Okay, yeah, so I'm gonna try and build this source code. Okay, so we'll clone this down. Okay, now you need to run configure or something. Okay, I'm running this. Okay, I'm missing like auto conf or auto tools or whatever it's called. And there's like this whole science to it. And it never worked. Or I did something wrong at some point. PKG config and stuff that's missing, and yeah. I mean, it worked better on Linux. On Windows, it's like a nightmare to get that stuff working. At least that's how it was like some years ago when I tried it. For me. I'm just not experienced enough in that area. I'm not sure how it works nowadays, but if there's better tools or stuff that makes it more automatic. I just wanted to install compatibility thing. That's why I'll go with batch. Right. So why don't you use Zig? I think the build system is pretty simple. And you can use C libraries. You can just import C libraries. You can clone them down with Git and import them. And it just works. You can also, like, you can set flags and do whatever. What am I doing here? Oh, yeah, I did the initial stating. There we go. So now that's done. This one doesn't have a intermediate thing that's there. Okay, cool. And we can now remove all this crap. Okay, so next up is destructible tile. Idle destroy. Destructible tiles should always be idle. Oops. Destructible tile. State. Right. That's that done. Enter area activate. I think this is the last one actually. And this should always be idle. There we go. Remove you. And we don't need this. And we don't need this. And we don't need this. There we go. And okay, yeah, and we need to change this. I mean, basically now we've got something going on here because we have like this store devices. We have this sort of same thing going on. Okay, we have, where's that other store? And restore is also the same thing. The only thing that's changing is the type and the map. So if we produce a list of types and map pairs, we could just loop through that, right? So I will just make that. So device I guess what would this be, like device okay, I'm just gonna call it info or whatever. Okay, device type and map pairs. All right. So I would have to learn Zig first. Yeah, but I already know C fairly well. Yeah, that's the problem. But it's probably easier to go from C to Zig than from, like, I don't know, C# or some garbage collected library, some garbage collected crap to this. Let's see. So this would be a list of tuples with a type and a map. Oh, but this is gonna be okay. This is actually interesting. We have a state, so this could be like any type, maybe. Can it be any type? I don't think so, actually. This is interesting. Can we produce this? We can't do this, actually. No, we don't even have the map here. Okay, let's do this. Let's do like persistent devices, which is a list of types, right? So I'm gonna take all of you, put this here, and there we go. Okay, that's the types that we have. Okay. Yeah, I want to learn it. Do it. There's a few languages I wanted to look into, but part of me enjoys the simplicity of C. Yeah. So, what about C makes it simple, do you think? Because I think that, I mean, of course, C++ is like just as sort of, it could be sort of just as low level. It also memory managed, but it has all these weird, you know, functional features and stuff. And and C is more focused. It has this way of one way, almost to do things. Yeah. And I feel like Sig is kind of like C, but it's, I guess it might be, because of the comp time stuff, it can be more complicated, but it doesn't have to. You can actually think in C while using Zig. It's basically, you can just go into Zig with a C mindset and do the same things. At least that's what I think. Because, you know, you have structs in Zig, which is basically the same thing. You can even, like, when you import a C library, you can sort of, you can say, well, if you, let's say you have a struct called I don't know, position or vector or something. And then this is like an external struct. So you just do this, and then this will be sort of your external struct there. Okay, never mind. The basic thing is that the structs in here are basically the same thing. And you can even define C functions in Zig as well. You can call C functions from Zig. Yeah, so there's a whole interoperability. If you are reliant on like C libraries, you can import them into Zig, and do that. For example, say I want to make a plugin system. Yeah, there's only a few constructs which prevents from philosophizing that much. Struct union enum functions. Yeah, that's the part here where, you know, okay, I tried to put off implementing patterns that I saw for a long time. But now that I see, okay, we have patterns here, I'm just generalizing things. The thing that Zig enables you to do is do it in a type-safe way. In a comp time type-safe way. You know, in contrast maybe to C then, which you would maybe use, you know, void pointers and you know, stuff like that. So it's like you can have void pointers in Zig, but I would advise to avoid that as much as possible, because it's not really safe to use. If you have the alternative. But for this thing here, for example, we're making a list of types, and then I can use that to automate some things in the code. And so it's basically, yeah, you get these new tools. It's like C, but you get a little bit more tools. But you don't get like classes. There's no such concept as classes or anything like that. If you want, you can actually sort of make classes as well, but you have to sort of make it yourself with the comp time stuff in that case. I mean, I'm not even sure if it's possible, like if you could to have like, I mean, there is such a thing, like almost a thing like constructors, but there's not, I don't think there's no such thing as destructors in Zig. I'm not sure if that's even possible to have. But there usually you have a pattern where you have an init function that will initialize the data in the struct, and then you have a deinit function which will, you know, clean up any pointers, any allocations that is in there. But you can also just use an arena allocator to, if you want as well. So it's like you can make it very simple as well, even with the sort of allocations going on there. If you need to do something like that. But yeah, so here I'm thinking like we have a list of these types, and then what are we gonna do with that? Because I want a list of pairs of device thingy-marigaroos. Maybe, okay, like a persistent device iterator. Maybe we can make an iterator here. So how would that work though? That wouldn't really work. No, wait. No, we just need to map. We need to map the type to a... Okay, I think we can do this. I think we'll make a map from a type to a map. So we'll make like get device persistent device map. So we'll put a type here. This is going to be the device type. And then what we get back is the state map of that, right? And we also need the save thing as well, but that doesn't need to be a pointer. Okay. So let's see. now we can do an inline switch on T. Right? Or yeah, and we can say if it's a door, for example, we say return doors. Right? Isn't that possible? While for swing. Oh. Can you do this? Is the question. Okay. Then we will, and then when we are here, what we can do is we can basically loop through all of our dear persistent devices. We get this type out, and we can say store that, and the map is get the map of this device. And this might need to be an inline for, I'm not sure. Okay, my LSP doesn't report any errors, but I'm gonna try and run this. And of course there are errors here. I found a sweet spot, honestly, with using an older-ish C standard, and I get a fast compilation and simplicity. Not that I don't also like the ergonomy of other languages that are higher level or more powerful when it comes to metaprogramming, but for this current project, I just don't think it would be that useful. Right, that's fair. For example, with the setup of my compiler takes 0.01 seconds, literally, and my executable is 50 kilobytes. That's also an advantage of C. Yeah. If you want a really low sized executable, you can use FASM. But really, I looked into that, and basically, like, because when you, like, the lowest you could get if you just have, I think, yeah, even if you strip like libc and all that, it's still the lowest you can get with like GCC or whatever is I think it's like 4 kilobytes or something like that, or megabytes or not megabytes but kilobytes. But if you use FASM, it's actually stripped down way more. So there's something with the sort of the headers or something in the ELF or something like that it sort of automatically, like, I think it might be sort of the linker or something that adds a whole bunch of data there that's not really needed, but it's sort of there because there's a reason for it, which I don't remember right now. But yeah, whatever. I was working on open source rendering C and was only able to reach down to like 100 kilobytes. Yeah, so there's like a minimum size there for the executable, but with FASM it goes down even lower, so you can get like the actual size of the code and not like some padded. It basically pads some kilobytes in there for some reason, but you don't really need it as far as I know, but it might have something to do with security or something, I'm not sure. But yeah, that I did try once to make my own sort of programming language with my own linker and assembler, and yeah, I got to the point of having some sort of thing there, but I mean, I think most of the, like, getting there took not that much time actually, but then if you want to, things like dwarf stuff and like yeah, debugging information. Yeah, there's like this whole, there's so much work in it, like this. Yeah, I did the elf. I had my own linker that produced an elf file from scratch. I basically just read the documentation on the format and just followed that. It was kind of simple. You know TCC, right? No? What is that? Also reading, I also read the documentation on the, what is it called? Like, you know, the CPU that I have. I think, yeah, the architecture x86-64. It's a, yeah, that's a whole thing. It supports like older, the fastest C compiler. Okay, it supports like older version of C. And you can use it as a just-in-time, I think. Okay. Interesting. Well, I didn't know that. I you know, to be honest, I don't actually plan on doing any C programming ever. It's just that Zig fills my void with, you know, low-level programming. And I don't feel like there's any reason to learn C now when I can do it in Zig. And not C++ either. I'm gonna stick with Zig. Well, that's what I say now. It might change in the future, as things always do. Let's see. Wait. So, okay. What is the error here? Focus of War 31. No field name. Oh yeah. No, I don't need you. What's the issue? Devices for no name. It doesn't. It's right there. Oh, federation. Wait, federation. Oh yeah. Okay. Yeah, it's. Oh yeah. Oh yeah. Sorry, I need to put it back because I remember I actually use it somewhere, so I'll just put this back. Put it back! I got tired of my C++ project, so that's why I just tired of all the messiness. I want something that's limited in its feature set and still powerful. I think C is the best, still the best we have, and familiarity. Yeah, I don't know, man. I think, like, okay, I'm not a C programmer, so I don't, you know, I know about C. I've used C++ much when I was first learning. I started with C++, and you know, so I know a lot about C, but I never actually, you know, I never actually programmed in that way, in like only using structs, only functions, enums, unions, whatever. And it's interesting perspective, because it's like when you read the books and you know, stuff about modern programming languages, and you have, you know, more advanced or higher level concepts and stuff, and it just feels like, oh my god, yeah, this is just you know, program languages getting better and better. But then in reality, it's more like there's different ways of doing the same thing, basically. And what these more modern languages enables you to do is maybe having sort of abstractions in a different way to make some things into a pattern that you can think about, and maybe that's what's hard with C to do. But with C you have more of a simple way of doing things, where you can just do things one way and it works. But then when you start to try and use these more advanced concepts, then it gets more messy and more unsafe and stuff. So that's where I think SIG has also like a little middle ground there, where you can implement abstractions and more, but you can do it in a more safe way than C, I believe. So I don't know. It's still, as I said, I'm not that familiar with C, in the sense that I haven't really programmed it with it that much, and I'm not an expert in it. But from what I can sort of tell from the type of programming that it has, and comparing it to other types of programming, so which I program a lot in other languages, I can compare like different paradigms as well, and yeah, that's sort of my take on it. So I don't know, it's that what makes me not want to try C is more like, well, I feel like I already know what it's gonna be like, and I also have a feeling that it's not gonna be very pleasant because I compare it to, like, it's just about it's also about tooling and a little bit about sort of the syntax of the language and stuff. So yeah, it's pleasant. Yeah, I mean, you're used to it, so I guess I could get used to it, but I don't really feel like I want to, since I can do it in Zig, and I kind of lean towards making things a little bit abstract when I see that it could be improved a lot with some sort of abstraction, then I want to do it. But I am very refrained to do it until I see that it's actually gonna give me something here. Because it's so easy to get into the trap of abstracting something, and then it's so hard to change in the future. For games it might be a pain, I agree. Because the thing in games is you really do want some good type safe abstractions. Yeah. Better tools for managing memory, I guess. Yeah. C forces you to do things straightforward way first. Yeah. That's also true for assembler or assembly. Man, I tried that. It's just it's an interesting experience, but it's not something I would use for large projects, at least. It's very interesting to learn how it works. Gives you another perspective, and it also gives you a perspective of how efficient things actually are. Hey Yoshi boy, how's it going? It's going good. How are you doing? Welcome. I've been programming mainly in C++ since I was in high school, but only recently, like over the past 4 years, done some bigger projects. I started to learn patterns for how to do structure codes. Okay, cool. For example, I like operator overloading templates sometimes, depends on the project. Yeah. I think they actually avoided adding operator overloads into Zig because of something like I don't know. There are no operator overloads. There are also no function overloading as well. So that's very different also. You have to sort of thinking a little bit different way when implementing things. I think it's kind of nice also because it sort of forces you to have like an options struct that just does everything. You can also have you can also pass in like a union a tagged union and do it like that if you really want to have like overloading. But operator overloading, I think I don't know what the actual reasoning was. I think it just makes it less readable sometimes, or less. I guess it sort of makes it less easy to read the code quickly. Like you have to go in and check, okay, what does this actually do? Do we find just finding someone to chill with? Oh, nice. Are you into programming? This is a kind of gathering programming people. But that's kind of what we do here. I don't know. I just like discussing programming with people. And I'm also implementing stuff. I started to like watch videos and read books on Modern C and watch presentations like 2-3 years ago. I started to try and actively like learn how to structure high-level code and procedure language like C. And since I've been enjoying things way more. Nice. That's awesome. Yes, there are less features, but the fun is trying to be clever, limited set of features. Yeah, I mean, sometimes the simplicity actually makes it way more efficient and more easy to read and just better overall. Like, you know, people abstract things, you know, a lot sometimes. A lot, and way too soon. And it just kills, sometimes it can just kill the productivity. Because you need to add something that's a little bit out of the box, and suddenly all hell breaks loose because now you need to support this new pattern that doesn't exist, or you get a sort of each programming in a project is going to implement their own pattern or something like that. It's like, yeah, like having a more constrained way of doing things could be very productive. As well. Yeah, I've been a programmer for a bit as a hobbyist. I just finished messing with Quick Shell for the moment, so now I can use my time doing other things. Okay, cool. What is Quick Shell? I've never heard of that. Alright, let's see if we can figure out what's happening here. Did I fix something or not? Oh yeah, move the federation. Let's see. Now we get save. Okay, here we go. It's saying something here. Must be compile time. No, value is right there. Okay, so let's make this into an inline and hope that it works. So inline kind of makes it like comp time known or comp time thing. Else prong requires switching on type. Okay. This is actually interesting. I'm not sure if this actually works to have a switch on a type. Wait, where is the thing here? Yeah, so I guess this is like a nullable. Right. And then we'll do that. If we don't find the map, I guess we'll continue. Or actually, we should report some sort of error here. Could not find map for persistent device. And we can also grab the type name of the device. Alright. Now we're using compiler here because this is like in a compile time here, so I think that is the appropriate thing. And it could not find persistent map for persistent device stored device. Interesting. So does this need to be like comp time here? Comp time. I'm gonna try this. Return. And this will... Well, maybe this is enough actually. Comp time is better. Okay, yeah. By the way, I used to write C++ C, make cross-platform code using tons of libraries, and I was hating my life. That sounds really bad, actually. As I was saying before, like, you know, do you remember... Well, CMake maybe is different. I don't know. But you basically cloned... If you wanted to compile some random... You wanted to compile some random source code. Okay, now you need to sort of download a bunch of dev libraries. You need to find those. It was a horrible mess to find those libraries because they weren't named the same as, you know, what they were stated in the readme file or whatever. If it said like, yeah, you're missing this library, okay, where is it? How do I find it? How do I get it? It's, yeah. And you run this configure script, right? Do you remember, or did you do that? And they're just checking system sanity, stuff like that. Try and support every compiler on the planet. Whoa. Just horrible. And I learned to worry about what's important in the code itself, reliability, quality, performance, speed, compilation, regardless of the language. I think there's good code and bad code. It all depends on how you approach it. Yeah, for sure. I mean, I guess I had an obsession with creating things that are universal. Sorry for fun. Yeah, no problem. Yeah. I also had an obsession of trying to perfect, like, have the perfect abstractions, have the perfect code, and if I couldn't find it, I like persistently try to make something work. Like, I need this pattern to actually work. I need to do it in this way. So I'm constantly trying to find better ways of doing it. And I'm not saying that is bad, because that helps you learn a lot. Like, I'm doing it Zig all the time. Like, I'm trying to explore and find different ways of doing things, finding new ways of doing stuff, and just finding what fits for a certain purpose. And I don't think that's bad. I think because that's how you learn a good practice. But you shouldn't. What's different now is that I don't sort of end my project with just excessive perfectionism there. So, because that just killed all the projects. It's just I just lost motivation when I couldn't find the perfect code. And what's different now is I just accept that things are how they are, and I can go back and fix things later, or I will sort of discover what will work in the future. But I also have the means of seeing, okay, this works, this feels bad, this feels good, let's go with that, you know, and upgrading and refactoring the code. Because I feel like that helps in productivity in the future, but it also could hinder productivity in the short term, or in the first perfectionism is so bad in engineering. Yes, you have to fit the problem. Yeah, if you can do it with approximate answer, it's good. Yes. That's also, I think I saw a talk that actually woke me up a little bit on that. I saw there was some guy, I don't remember, he was talking about the code base of something, Twitter, I think. I'm not sure what role he had in that, but he basically just I think that's what he did. I think he just said that it was bad. But he also said that, yeah, it just needs to be good enough. And I agree to a certain extent. I feel like, yeah, if you want to get something out as quick as possible, it just has to be good enough. But I also feel like programming is fun, and it's fun to find ways of doing things. Like, it's creative. It's a creative process as well. And sometimes I just feel like it's fun to just go and refactor something, finding a better way of doing it. It's just a fun activity. So yeah, but yeah, of course, if you're on a deadline, if you need something to get out, it doesn't have to be perfect. It has to be good enough. Yeah, okay. I think it's fun. I should preface that with I think it's fun. It's fun for me when I know my code is at least decent at time T, and I can move forward with the next step. Yeah. And I'm beginning to feel like that's fun as well, because you can see the progress more, and you can also start to build larger and larger projects without having them die because of perfectionism. So if I'm not satisfied, then I can't move on. Like, this is a big problem. Right. I see, yeah. I feel like I'm being fulfilled by being able to build a large project and being able to continue to work with the project without losing sort of faith that it will get sort of completed in the end, or just losing motivation because I feel like, oh man, this is bad, and I just give up. That was the problem I had before. I feel like that's still a problem, but that's sort of what I'm battling with. And sometimes you want to do some fun, exercises and just refactor things. And I feel like it's also important because as the project grows, it's gonna grow into a horrible mess if you don't do it. So the hard thing is like finding the correct time to do things. So let's see what's going on here. 175 unable to have any comp time expression. Right, okay, so I'm thinking what we can do is, instead of returning the actual map, we could return a field name that you can use. So we can return either just a string, or we can return the field enum of this thing up here, which is we don't have a name for this, but I will actually call this persistent devices type, and I will create that here. Whoops. Okay, that is the persistent devices. Right, so now this, where is it? Here. This will be a field enum of persistent devices. Okay. And if it's door, we're just gonna say doors, right? Okay. And now that could actually be, instead of being a function like this, it could actually just be well, yeah, this could be maybe here now. This could actually be like this, a tuple of type and a field enum of persistent devices, right? So now this door is doors, this is toggles. And the more you actually exercise in doing stuff like this, the more you actually see, okay, this will lead to something that is good. But when you start to, when you walk down so many roads and you know that, okay, this won't work. So you just abort that idea and you try to find a better way of doing things. You know, explosive walls. Now this might paint us into a corner, but right now I've done it for so many devices. I feel like this pattern probably works. And if it doesn't, we can always change it. You can always add, you know, special cases. Maybe it's not even a device we're dealing with, maybe it's something else. But this seems like a pattern, so now I'm gonna implement it. That's kind of what I'm trying to do here. Now this, I mean, we could still have a function, I guess. No. Well, actually, you know what? Now we can get the, this could actually be a this here, but what we can do is we can get the field, we can return, no, we get the field, which is going to be persistent devices. Inline 4 or wait, no, this is switch on T, inline else, we get the type out, we check if the type is equal, no, what the hell am I doing? I need to loop through this guy, right? That's an array. Get the pair out, so we get the type and the field, right? If the type is T, we return devices, we return the field access with the field, and now we need to grab the tag name of that field. This I think this needs to be inline for this to work here, for this to be like comp time known. I'm not sure actually, but if we then don't find it, this needs to be, you know. Big part of it was blindly following what people were saying online. All right, yeah. Which part were you talking about? Sorry. I lost it there. Welcome back, Abbreviated. We are doing some abstract things here. I should have asked myself what is the most practical. I built my own extractions over the language constructs based on empirical testing instead of following internet dogma. Yeah, I mean, I feel like when you do things for yourself and you're, you know, doing the hard way, you're reasoning things the hard way for yourself, that's when you actually get a grasp on what's actually going on. And yeah. When I was new, I had no clue, but as you do more projects, yeah, you can just wait and need to establish more common patterns. Yeah, that's kind of what I did with this project. That's why I'm doing it now, because now I'm like pretty much pretty far in to the project, and I saw this pattern that was emerging for things, and then I implemented it. I felt like, okay, now is the right time because I see this pattern. I implement it. I need to stop doing it though, because I'm running out of of those things. So anyway, now, okay, yeah, this should work the same Although this is not a com time, or is it? Maybe it isn't. 216. Expected type found field. Wait. Um. 216. 53. Expected time. Oh, yeah. Right. Well, actually, we don't really need this now. We could just do. We could just do this. Right. We don't need this. We could just say the map is equal to this field access, and that should be enough, I think. And if this doesn't, you know, if yeah, whoops, pressed the wrong thing. I listen to people's ideas now, but I don't automatically follow. Good. Like, unless it is something that objectively improve my code base. Yeah, you should always take things with a pinch of salt, because I feel like a lot of people also online, or you know, on platforms and stuff, they want to be very assertive, and because that's when people listen more as well, so that they get more views and more, you know, stuff. So I feel like that's also a thing that you have to be wary of, and get your own perspective on things, get your own view of how things, you know, what works for you. Yeah. All right, so now we can remove all this. It's automatic. It's automatic. Well, it's not 100% automatic, because the thing that we actually need to manually think about is what devices should be actually saved, and they are these ones. So we have to put them in this list. If they are in this list, they will be automatically handled with both loading and saving. If they are not in this list, they won't be saved at all. Okay. And well, now this one we can just get rid of this here. Okay. However, we still, okay, so we did this for what device type, store devices. Yeah, so the devices for storing is automatically now based on this list here, which is really nice, but it also forces us into this pattern. But yeah, it works for now. Okay, what's bad about this though is, like, whenever in the future I need to go into and look at this, I'm just gonna be like, what the hell is going on here? This is the problem here with this. But yeah, that's just how it's gonna be. It's not really a huge system, so it's not gonna take that long to actually get into what's happening. But anyway, what are devices? Good question. It's basically anything in the game that can be, how would you put it? I guess activated and deactivated. Well, it doesn't need to be deactivated, but it basically has a state where it's either like on or off, or maybe it can have multiple. Like how it works right now is I have a concept of signals. So you put like sort of like redstone in Minecraft, if you're familiar with that. You get a signal into a device, it will be activated and do something, Like for example, we have a block that gets retracted so you can't stand on it anymore, for example. Or you have a door that opens or closes depending on the signal. So when it has a signal, it's open, and when the signal is off, it's closed. So can monsters be devices? No. Well, they are not devices because they can't receive a signal and be activated with a signal, basically. I mean, it depends on how philosophical you want to get with it. Technically, almost every monster has like a waiting to spawn state when they spawn first. So they don't, it's like they don't exist first, but they do as an entity though in the code. But they don't exist until you get close enough, then they actually spawn in. And that you could call that an activation, but you know, it's more like things that are not living that can be activated, I guess. They wake up if you enter an area. I mean, yeah. I mean, technically, that could be a thing. It's sort of how it works right now, except it's like proximity of the player is almost always how it works. However, each monster actually has its own way of waking up right now. But I guess that could be sort of a common concept. But right now, it's like per monster. So each monster has its own way of dealing with that. So if you go to, let's say this guy, for example. Now, I did sort of abstract this. Well, I have this default spawning state machine that I'm using, which most monsters use. So first you have the initial state is waiting to spawn. And when the player gets close enough, which has happened in here, if the distance to the player is less than some sort of threshold, we set our animation to spawn, we play some sound, and we set the duration to as the animation duration. Then we also change the state to spawning, so there's a spawning animation going on. And yeah, there's also some sort of default damage behavior. If the player hits a spawning monster, it's gonna be automatically sort of completely, that is gonna be spawned complete. The spawning thing is gonna be complete. Or if the duration ended, we're gonna also, you know, trigger whatever is gonna happen after we're spawning. Now, there's not what's sort of missing in this state machine system is having a common concept of these states. So basically, each state machine is kind of unique, and there's no real way of actually checking if a monster is in a waiting to spawn state or not, because they are all different state machines. So that's where this has a weakness, basically, to have like a common thing happening. However, how I'm dealing with this is basically the default spawning state machine. So I have this default behavior that I can change, which will affect everything that is using the default spawn functionality. So that's how I can sort of commonly change the behavior of this, which also applies to sort of things like walking, for example. We have a walking state here somewhere. Walk, which we have this default walk behavior that all monsters could use, and then you can tweak some stuff like this one, for example. Well, we have the walk speed for one, and then we also have like turnaround if we're on a ledge or we're blocked or something like that. So it's like walking randomly. You can set a duration. You can, yeah. So, and if we want to change something about the walking for all monsters, we can do it in this function here. So, but that's kind of like sort of like a weakness. There's no real way. There's no real like common concept of walking except for this function here. So if we're not calling this function, we have our own walking system or own walking behavior for one monster, for example, then that's not gonna get affected by changes in this function. And there's no real way of fixing that, I guess, except for adding like a component. Like if you're walking, let's say we automatically, or not automatically, but we're adding like a we could add like a walk component or something like that. So we're adding a walk component. Now we know it's walking, so we can do something with everything that's currently walking. You know, you can do that, but it's just I don't know. I guess we'll see what's needed or not. I'm not sure if that's a good idea, but I'm gonna try this out for now, and we'll see. For now, this works really well, and it really enables you to see everything that's happening in one monster. Now this monster is kind of complicated. It has like a lot of different behavior and states that are happening in here. And usually I also don't have, like in the state machine struct, in this one I have like almost all functions that related to the state machine is in here. But I realized that maybe that's bad. I should probably move out like helper functions outside of this, because then it gets more readable to what states actually exist. And yeah, anyway, good to occasionally see your to-do list. Yeah, of course. I'm thinking a little bit on how to do that. I think one stream I added a little thing here that I said like what I'm currently working on. So basically refactoring stuff, let's say. And yeah, I need to get into habit of doing things like that. I could also add I do have this milestones, which kind of is like my current to-do. I have an older to-do list as well, but that's getting like out of hand. So I made one that is like more maybe abstract here. And I also haven't updated this, but maybe I can do that. I guess upgrade is done, sort of. Monsters, probably. I do want to add more types of monsters, but I'm just gonna tick that off for now. I guess it's basically, I want to also flesh out the forest area, so that's what I'm trying to think here. So what's kind of interesting about this game, I guess, is, yeah, you have this area that is like the monster area where you have a boss, you defeat the boss. And what's gonna happen here is, first the area is sort of like dead. It's like everything is like ashes, or, well, not ashes, but it's sort of like decomposed, I guess. It doesn't have, there's no life in the area. But once you kill the boss, you kind of restore the area back to life, you could say, in sort of a semi state, because it needs time to sort of revive. But then you can access more things. You have like maybe vines that grow that you can climb up and stuff like that. So you can access more areas that you couldn't before, and then you can maybe get to, you know, things, finding secrets and stuff like that. Yeah. So that's gonna be interesting, because I have not done anything with that yet. Okay, and here's the village. We have the basic, you know, structure for many things, not shops though. Although I'm kind of a semi system for that in dialogue system. Crafting, sort of also semi, but I think I'm gonna try and, you know, add a specific UI for that. Also not sure if it's only gonna be done in certain spots, or if you're always gonna be able to do it, or whatever. Like, there's a lot of things I need to do music sounds. Oh yeah, one thing that I actually noticed, because I was playing Silk Song, and well, there's no spoilers here, but it's like when you jump, I noticed something. Like if you jump, let's see if I can I run this now? No. Well, let's just run the thing. Oh, it's running in Linux. I didn't want that. Get out. Okay. Let's do. Actually, I don't need to. I can just do this. All right. Well, okay, it's gonna be hard to show you here, but if you jump like this, and if I press jump and I press jump again before, yeah, you can jump really high. If you press jump again before you land, in this game you don't actually jump. You have to wait until you land in order to jump again. And I've noticed when I played Silk Song that they actually have a different way to do that. And when I switched, and I noticed it because when I switched back to this game, which is kind of, you know, it's similar, it's like 2D side scroller, it's a Metroidvania, it's basically the same game, but when I started to notice that I tried to jump, sometimes it didn't jump, and I was like, what's happening? I'm fairly sure I pressed the jump button, but it's like in Hollow Knight, I'm not sure if it's in Hollow Knight as well, but in Silk Song, it's basically as soon as you press jump again, the character is gonna jump again when you land. So it's not like you can hold jump and it's always gonna jump, like, you know, as long as you're holding it. But if you press jump a little bit before the character lands, it's gonna jump. So, and I just felt like, oh man, sometimes when I try to jump, it felt like I should have jumped when I didn't. So I think that's actually a nice little, you know, detail there that I should have. So I'm actually going to put this down here in somewhere. Gameplay maybe. Jump. I already ticked jump off, so it's done. We can't change it. No, but I wanna do if you press jump while falling, and if you're still, well, it's kind of weird because it's like, do you hold it? Should we jump if you just press it and what happens if you release it before you touch the ground? Do you still jump? You know? Yeah. If you do it, then you also do canceling. Yeah. I mean, you can just if you release the jump button, you won't jump, I guess, because we have a cancel. We have like you can jump to a variable height depending on how long you're holding the button. So you can do this. So I guess if you like release it immediately, there's gonna be either like a very small jump or no jump at all, basically. But I'm not sure actually how it works. If you, I mean, I don't want to copy it straight off like that, but it would be interesting to try an experiment to see if you release the button before you land, will you still do like a tiny jump, you know? Because also in Silksong it's also like variable jumping. So if you want to jump, you normally hold down the button until you jumped as high as you want. So if you press hold by falling, you're still holding the button. And execute another jump. It's also the question because my game is gonna have like double jumping. Also, Silksong has, well, I'm not gonna spoil it. But there's like, you know, a little quirk there. Are there any other moves that require us to be grounded? Well, I'm not sure. It's like I don't really know what we're gonna have. I've been thinking about different types of upgrades and abilities and stuff, but there's nothing that's there. Like it's still very up in the air what's gonna happen. So I think this is a good thing to have in general, you know. So yeah, there is crouching. Picking up items is like automatic right now. It's like as soon as you move to like an item, it automatically picks it up. But I'm also thinking about making it more like Hollow Knight there. Like you have to sort of press a button to actually pick something up, because maybe you didn't even realize there was something there and you don't know that you picked something up or something like that. I'm also gonna add a little notification thing, a little sort of, yeah, you know, a little icon in the corner of the screen or something. You picked some item up. It's gonna show somewhere. But if the player can only cast magic when on the ground and try to cast oh, you mean like that? Okay, yeah. Well, for crouching, it's just gonna check if you're on the ground. You have to hold the crouch button, so that's not gonna be an issue. Attacking you can do whenever. Yeah, that's a good point. Like, check if there's any other actions that requires you to be grounded and should activate if button is held down. Wow. While landing, I guess you could say. Yeah, good point. I didn't actually think about that. I just noticed for the jumping there. But that's something that is like could be sort of a source of constant frustration. Like, man, I thought I jumped, but then I didn't. You know. Yeah, but yeah. So what I'm trying to do here is basically painting out sort of the, I guess the demo. First sort of alpha demo version or something like that. I don't even want to put a title or whatever or to it. It's just some sort of milestone. I guess the main thing is I want one area with a boss. The boss is basically complete now. It's just the polish and the graphics. But that's actually really nice to have that done. But then we have like, you know, I want to flesh out the area, basically extend it a lot. Like right now it just feels like a mini version of what it should be. And yeah, adding things to do, more different like items that you can craft with and stuff like that. Village like quests, stuff like that. So yeah, there's some there, and you know, music and sounds, polish things, graphics, filling in missing things. Yeah, so but I do have some sort of vision for what this first sort of version is going to be. and we already have like sort of some upgrades like double jump and the lens beam focus thing. So yeah, but I would like to add more like combat stuff, so it's more fun to do combat as well as sort of traversing. I've been thinking of more like traversing the terrain, so it's more fun actually walking from place to place and not just walking normally, you know. Yeah, so that was a little bit on the to-do list basically for the game. So yeah, there's some things to do. Now let's see if we can make this work here. Okay, use of undeclared identifier pair. Right, so we are going through the devices, right? So this is the pair, this is the pair, that's the pair, there we go. And this is T. Oh, I guess we can call this device, fine. Alright. It's gonna be really interesting to see if this actually works. 192 operator not equals not allowed for chest state. Okay. Oh, because it's like a okay. The chest state is apparently special. It's a tagged union, I guess. Yeah, it doesn't need to be, so we will just make this into a union, or I mean an enum. So yeah, that's that. Should probably go through everything else as well. I think Fog of War also has the same problem. Yes, because it used to be a tag union, but now it doesn't need to be. What else do we have? Well, yeah, I think explosive wall. Yeah, explosive wall. Yes, I do remember having to change that. Okay, what else do you wanna complain about? Not allowed destructible tile. Okay. I mean, we should just go through everything, I guess. Door. Good. Whoops. Let's hide you for now. Delay is good. That is good. Good. Wait. What's this? Oh yeah, the button doesn't even have a state. For war, time toggle, explosive wall, steering wheel, here we go. It can be changed as well, but you're not persistent, so it doesn't really matter anyway, but whatever. Oh, and this one as well. Nice. Simplifying as well. Really good. Alright, let's see now. Still complaints. 194. What's your issue? Expected. I'm guessing it's finding a constant. Yeah. Okay. So this needs to be a pointer there, which means that this needs to be a pointer, which means that this needs to be a pointer. There we go. Which should be good now. Oh, is it done now? Nice, nice. Man, I've been playing so much Silk Song. I was putting it off, but then I started to see a bunch of recommendations on YouTube, and I didn't want to get spoiled, so I decided just to start playing it. But I didn't want to get, you know, as we say in Sweden, we say colored. How do you say? I don't know. Like, I didn't want to get tainted by the features of the game. But I think, yeah, it has helped maybe. Let's see. What the hell? Yeah, okay, yeah, it compiles. Great. Okay, so now it's just a matter of testing. Also, we need to do this one. Yeah. The restore devices as well. So what do we do here? Here, we also want to go through persistent devices. We get the pair here. This needs to be at 4. We get the map, and then we call restore device type. Device. Oh yeah, so this is kind of different. I played the first one a long while after its hype has died. What did you think about it? You mean Hollow Knight, right? Because that's the first game. Yeah, so I think I will change this. We'll make a view here instead. And we'll go through the view. Oops. 4 devices. We don't. But yeah, we need that. I'm also gonna make a context. Excuse me. Make this into registry. Right, we don't have you. We don't need. Well, we do need the map, I guess. Yeah. And we don't need to check if it has the thing. Now we get the state. We don't need to return like true. We just return. That simplifies that as well. Okay. Restore state. And we call restore state on that. Yes, that's all we need to do. And yeah. T is... We don't really need T though, but I guess we... Well, maybe we actually do. I don't know. Okay. Now this one, we'll go through everything. We will restore the device type. We'll add T here. There we go. Now I think we can just remove all this crap. Oh my god. That's so nice. It's all abstracted now. Woohoo! It was lovely. I love the audio the most. Yeah. But that's the funny thing. Like, I'm a total like gameplay nerd, so I actually didn't even, I didn't even notice the music. I mean, of course it was like a pleasant experience. I actually didn't like the graphics at first, and I still don't really find it. I like the environments, but not the characters are kind of like meh to me. I don't know. I don't want to, it's an awesome game. It's like one of the best Metroidvanias ever, but I don't know. There's something about the graphics that doesn't really, because that kind of put me off at first. Like when I saw it, I didn't know about the hype, or I didn't. I think I played it when it was very new, and I saw it and I was like, yeah, I really love Metroidvanias, but it doesn't look that appealing to me. But then, I started playing it, and yeah, the gameplay was just so good that I just kept going, and yeah, it's just so good. And the music is like, yeah, it's whenever it's like ambient like that, I don't really pay much attention to it though, but I did enjoy it very much. It has like really good music, and the sound design as well. It's like everything is just so good. Let's see. The store devices, yes. Can we run? Okay, well, it's still, we don't know if we can actually run this. No field manufacturer restore device type in save. Oh, so we do that. There we go. I'm not the biggest fan of Metroidvanias, but I remember the sound is what immersed me. Okay. So what is that you don't like about Metroidvanias? Or what is it that you like, and what is that you don't like? Because that's gonna be very interesting. I mean, you say that you like the sound. Is there anything else you like? And what did you not like about it? What is that like the... Well, I'm not gonna taint your answer there. But I do have a... Most people complain about a specific thing I'm gonna talk about. I like the mechanics, it could be satisfying. Right. Yeah. I really like when, like, the high points for me is like when you defeat a boss, or you know, some sort of combat situation, and you get your heart pumping and adrenaline going or whatever, and it just feels like you're completing a tough challenge. That's really nice. What I don't like is seeing a level and area at the corner that I can't reach. Oh man. Yeah, okay, I get what you don't like Metroidvanias in that case. Because that's like the core thing about Metroidvanias. I could just look at it and have the idea that it will require double jump ability. Yeah. That's also the thing, like when you're playing a new Metroidvania, if it's a good, then you don't really know, okay, what kind of thing will I get to reach there? But I have to revisit already. Yeah, if you do it right way, and I have an example of that, it's Super Metroid. If Super Metroid actually has like a path that you go through, so you don't actually need to backtrack per se. They actually designed the whole world so that you could sort of follow a path and don't have to sort of, you're gonna visit the same areas, but you're gonna, you know, just go to, you know, go into you know, you're gonna follow a new path in the same area and get to a new place that you couldn't do before. So kind of like crisscrossing across different areas, but you're never sort of following the same path. So that's kind of how they designed it, I think, and it's quite genius actually. And but the thing is that when you're new to the game, you're probably not gonna follow that set path. You're probably gonna try and explore and do things that you can't do, and then, you know, you're gonna have a whole bunch of backtracking. I think what they sort of improve on that in modern games is like putting up barriers in places where, okay, there's no point in going back here, so we're just gonna put a barrier here so you don't waste a bunch of time going back, you know. And I am thinking about those kind of things as well, and making it like minimizing backtracking, I guess, as much as possible. It's up to the player if you want to backtrack, if you want. Like, it's like the thing is that whenever you get a new ability, you know that, oh man, now I can visit all these places that I couldn't before. But the thing that the developers did was you could still follow your main path and get to those places later, because you're gonna go through that path later, because that the main path is gonna lead you through all of those missed places. So you're gonna be able to go to those places anyway, so you don't have to go back and backtrack and then visit all these places. You can just go through the main path and still get to everything. That's kind of what they did with Super Metroid, which is really amazing, actually. I thought, because I replayed that a couple of months ago or something, and I just realized that, man, they really did a nice job with the level, with sort of the world or the pathing in the game. It's not always, to me, what is a barrier versus what is a skill test. Yeah, that happens. Like what is it called when you skip something? Yeah, just a skip, I guess. Let's say there's a tall jump. Do I hop over monsters to reach it? Do a double jump if there's a few flying monsters? I might just try and not stop to reach it, or maybe there's a wall. Yeah. Yeah. I think it's gonna be different for each player. It's gonna be sort of hard to make it so that everyone has the same experience. That's basically impossible, I think. But you can do stuff to help. I mean, a barrier to me is just, you know, I mean, either it's a place that's too far to reach, or it could also be just a door that's in the way that you can't open, or just a wall. I mean, in Hollow Knight and Silksong, they use the like shortcuts a lot. You have to go through the long way first, then you open up a shortcut. It's kind of like Dark Souls as well, that you do this. You go through the long way, you open up a shortcut, and then the next time you go through, you can go through the shortcut. But that's also because they have this kind of mechanic where if you die, you respawn at the sort of starting point that you have set, the respawn point, and you have to sort of backtrack back to where you were. That's one of the things that I don't like as well. It's like, because every time it just feels so bad. You have to walk back to where you were, get your stuff back, and it takes forever if you ventured way off and you didn't find a save point or whatever. So I'm gonna try and think about how to fix that. But of course, there's also a point in having to feel bad when dying. There's like a point to that, because it's gonna feel better when you actually complete something that is hard. So there's like a balance there, I think. Okay, what's going on here? Expected type, blah 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 blah, found blah 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 blah. Okay, so you found a pointer, so let's make it not a pointer. There we go. And save. You are what? Expected. Found this. Right, so this is like .id. I really hate that my LSP just stops working randomly. Or it was like after a reset or something. I reset my computer. Restart. Maybe there's a wall. Do I bring explosive monster to it and break it, or will I require a heavy attack? I mean, yeah, but that's also the thing about the exploration part and the... Actually, have you played Symphony of the Night? Because that has like a ton of... unique interactions that is maybe kind of hard to figure out. But once you do figure it out, that's just an amazing feeling. So it's like, you know, it's like pros and cons, I guess. Oh shit, I have to leave here soon here. Okay, let's just get this working here. Oh, it actually launched. Okay, let's try and see if this restores the state correctly now. Okay, interesting. Well, I'm not sure if it did, but I will activate. No, I won't, because I don't have the activation thing. Well, let's go to upgrades. Where is this thing? Here has focus lens. Let's change that to true. Let's remove the saved file. Let's run the thing. Does this work? Why does that not work? Okay, there was a way to do this, but I forgot. So this is apparently, well, it's not working anyway. Let's just go here. And we have the plane component. I'm just gonna manually. Why? Do that. Oh yeah, I have to run the game as well. What's your issue now? Expected. Oh. Yeah, I guess that's also like something that is sort of, I don't really have that problem actually with Metroidvania. I think that is something that is like you kind of have this common language between Metroidvanias. Like you kind of know, or you get the intuition the more you play them, like what will work and what won't work and what you can try to do. And I think that Silksong and Hollow Knight is pretty good at giving you clues to what actually works and what doesn't work. For example, if you hit a wall, it will behave in a certain way to make you know that, okay, you can break this wall, or you can't break this wall, or it's like a door, but you can't break the door. It just, you know, you hit it and it will make this dong sound, and then you know, okay, I can't break this door or whatever. So it's pretty good at giving like hints like that. I feel like that's part of what makes it a good experience as well. Wait. Okay, now we have the lens. Okay. I think maybe the other thing did it before, maybe worked. But I think that's also, yeah, that's something, as I said, like you get more and more like intuition on what's gonna work and what's not gonna work. I'll try. Okay. When I play this, I feel it's so like I feel like I want to do the moves in Silksong that I don't have here. But yeah, so let's do this. We have a chest. We have some Fogs of War that we did. and the explosive wall. So let's see if they load properly. Please do. Oh no, there's a crash. It's a crash. Okay. Why are you crashing? We're trying to remove something. Okay, in a state machine. I see. Okay, and let's go to that. Where is it? 1, 2, 3. Remove. Okay, yeah. Remove and then destructible tile 61. Okay, so there might be an issue here then. We're trying to remove a death component, so and we might not have it. That's the issue then. Okay, 1 second. I'm getting a call here. All right, looks like I can continue a little bit more. Yeah, let's see if it's okay. There we go. Yeah, and it restores correctly, and the chest is also open there. Cool. Let's also check. We have a bunch of different devices over here, so let's see if this also works. Okay, there's a crash. All right, why are we crashing? Oops. Warning. Reached unreachable draw. Interesting. Wait. Okay. Well, this is one of the cases where we can't really see which device is there, but I think if we do like remove something, I'm not sure what it would be. Maybe rigid, maybe draw layer. No. I mean, we have explosives. No, those things are already. They already work. So what devices are in this place? We have the toggles, the doors, the buttons. Yeah. So these things don't restore. These things, I'm not sure. Yeah, I think they do actually restore. The doors restore, the toggles restore. The doors might be the case here. I'm gonna try something. I'm gonna move to this area, load this in, and activate this door and see if... Oh man, I'm trying to do Silk Song moves. Okay, so now this is open. Let's see if this still if this crashes. No, so it's not the door and not the toggle, I guess, unless it's like a race condition. But so it might be these guys, because they are basically the only thing. Yeah, and that guy, I guess. But we did not. We did. Did we even have anything here? So it's actually crashing before actually doing anything, I guess. Okay, I'll remove the save file again. Whoops. Will it crash? Yes. So it crashes on a blank slate. All right. And the thing that's crashing is, wait, could not say. Okay, yeah, that's not the crash. Here's the crash. Yeah, so we're trying to get something in the draw system. I'm gonna go and see what this is. Actually, could I go to this file? Yes. Well, okay. Please go to the file. There we go. What was it? Draw 106. Yeah, I was trying to get the body, but it doesn't exist. Oh, we're going. Oh yeah. Wait, but I think this is the whoa, what's happening here? I'll just quit. Whoa, what the hell? Input output error. What is happening? 1 second. I think I might need to restart. Okay. Oh, it found another window to go to. Great. I'm gonna kill this. Okay, please don't. Interesting. Okay, let me do. Am I getting hacked or something? 1 second here. I'm gonna. Go and I'm gonna shut down WSL. All right, there we go. It's shut down, and then we'll restart it. I hope that it works. Interesting issue here. Maybe I was thinking maybe it has something to do with the network, but it's looks like it still works. So yeah, what's happening? Wait, did Western just not work? Start up? It just gives up here. Okay, I'll try something. Let's see. mean, usually when I shut WSL down, I can also like start it with fail to start. Okay, well, I guess I will have to figure this out. Well, I guess that's gonna put a stop to this stream here. So yeah, this is very, I mean, I might need to restart my computer or something to get this working, but I think that's gonna be enough for today, actually. Maybe I'll try one more time. Wait, now the West term started, but it's not. It's taking a while. Create instance failures. Something is going on with Windows here. I'm getting hacked or something. I don't know. Okay. I'll just put a stop to this, and yeah. But thanks for watching, and yeah. I hope I'll see you next time if my computer still works, and yeah. Let's end this here. So yeah, I'll see you later. Have a nice day. Bye.